So this panel is entitled Infrastructure 2.0, the Coming Network Revolution. I'm Greg Ness. I'm on the SNS advisory panel and out of Silicon Valley. And basically, we're here as a panel to kind of ring the alarm bells a little bit when it comes to network infrastructure. And classically, when people have talked about networks, it's been about speeds and feeds and capabilities. And the last 5 or 10 years, obviously Mark's talked about this a lot, plenty of people around the world, about the bandwidth being a very strategic part of innovation. Well, today, it's a little bit different twist on that. That is, today's networks are really run like yesterday's businesses, like yesterday's factory floors, with legions of what one Cisco executive called clerks, manually configuring these networks to keep them available using tools like spreadsheets, checklists, and committees. So while cloud computing and virtualization are decoupling applications from hardware, and cloud is decoupling IT services from hardware, the question remains, how do the networks keep up with these levels of change, more IP addresses, more movement? And some of the very powerful enablers of cloud, the business models, require substantial levels of movement in between data centers. So our panel is basically going to be in 2 parts. The first part is going to be a little geekier, a little bit about some of the critical points in the differences between the 1.0 infrastructure we have today and what we need to evolve, the 2.0. And then the second part is going to be about the kind of macroeconomic, business, commercial implications of what this is all about. And if you are drawing allusions to just-in-time manufacturing and the investments made in those and how that influence both the wealth of companies and the wealth of nations, you won't be alone. So basically our panel here, I've got next to me Rick Kagan from Infoblox, which is where I also work. They're leader in automating the core network services that keep networks available and secure. Next to him is Mark Thiele. So he's from he's from VMware, right? You still there?
Yes, I am.
Right. So, and he's in the awkward position about being an enabler of this new world and putting these new demands in the network, and yet running the data center operations for VMware, keeping these networks and systems available in high performance and high secure state. So his perspective also be very interesting. We have Erik Giesa from F5 Networks, clearly a premier leading company in the application delivery space. And we have Gourlay that joined us this morning from his personal jet ride from Las Vegas Networld Interop, where we both were a couple days ago, as well as Erik, from Cisco, the premier networking company. So each one of these panelists represents a very unique vantage point on this issue. So why don't I, with that, cut to the questions. You guys ready?
Yeah.
So Erik, can you tell us what is Infrastructure 1.0?
Well, a lot of definitions, but I think the salient point is what are the characteristics of a 1.0 infrastructure? And typically, it's a tight coupling of user to resources. Now, like you said earlier, virtualization, server virtualization has really changed the game, but that's been around decoupling the operating system and in some cases to the applications from the physical hardware. But what hasn't transpired quickly enough or kept pace quickly enough until recently is the infrastructure itself, the network architecture. That's changing. We're going to be talking about that. But traditionally, in a 1.0 architecture, you still have the tight coupling of users to resources and the network itself. And this is characterized by tremendous inefficiencies, both from a capital expenditure as well as operational expense, and also just a lot of inflexibility.
So while systems are becoming more mobile, more dynamic, the network is still kind of stuck in the static world a little bit, in the tar pits a little bit. So Richard, anything to add to that in terms of 1.0 infrastructure?
Well, yeah, I think it's like what you said before. It's really about a lot of manual processes and tools trying to operate this very, very complex, increasingly dynamic network by hand. I mean, imagine if when you went down to the local wireless store and you ordered a new wireless phone, they said, come back in 2 days and I'll give you your phone number. Now that sounds absurd. If what they had to do was put a call into somebody who was then going to go call someone else, who was going to then look it up in a spreadsheet to see if there was a phone number available for you, call that other guy back, register it in the billing system, and eventually you'd actually be able to use your phone. I don't think, you wouldn't go back there again. That wouldn't be a great enabler. And yet if you look how an awful lot of enterprise, larger ones than you might expect, actually run their networks exactly that way. If a guy who wants to put up a server in an application wants to get an IP address, for example, for that application, that's exactly what he does. And he'll wait a couple of days for the network team to get back to him. So there's this huge disconnect between this very, very dynamic and mobile application and OS and infrastructure and these enormous investments being made in big pipes, and the poor clerks running around with very, very basic hand spades trying to keep it all going and satisfying this very dynamic environment.
It's almost like one of the big ironic twists of IT that it would be the equivalent of going into Microsoft into Steve's office and seeing a typewriter with carbon paper. It's the exact opposite of what the effect is on the enterprise, but that hasn't been absorbed into the culture of running the network. So, Mark, in terms of the data centers, what does 1.0 mean to you from a data center practitioner, knowing full well that you're at VMware, which is basically changing the landscape dramatically?
Absolutely, and I love VMware for all it offers, but my perspective does generally come from the person who has to own and operate the environment. And when I look at virtualization and I look at the network and I think of what the opportunities are, I see really two different things that have already been enabled, right? From a data center platform standpoint, regardless of whether it's VMware's virtualization, there's an ability to separate what goes on in the data center from the hardware. And so you've got this kind of floating mass that's got all these borders around it. And then right outside the wall, on the other side of the borders, are these great big pipes now that are available and they're fairly inexpensive. But between that floating mass of systems inside the data center and that huge pipe on the outside of the wall are some lights, basically, for traffic that don't work very well and have to be manipulated manually. And so when I look at systems for my environment, again, as a user of systems in general, I look at systems for the environment and I say, what I want complexity in the system, but ease of interface. And today it's, going back to what you were just saying, it's just the opposite, right? The complexity is on the front end and the intelligence is not in the back end. And we need to reverse that. We need the system to be able to help us move more quickly and adapt to the environment. And today, the network's not capable of doing that.
And Doug, obviously I've listened to you speak on this topic a few times, and you've talked a little bit about the big picture implications of what this all means from the standpoint of the U.S. economy, business climate, as well as the environmental energy consumption picture. So what do you see as the big picture implication of what we're talking about, the problems and challenges?
Sure, Greg. The first thing I'd probably say is let's look at 3 or 4 little facts that kind of fly with this, which is tie together a lot of what you just heard. Gordon Moore wrote his law and said that, hey, transistor density is going to double every 2 years. And what we heard from that is CPUs will get faster every 2 years. We hit a speed limit around like 4 gigahertz or something, and they stopped getting faster. They started getting wider. Now you see multi-core and all these things happening. There's an inverse of Moore's law you could apply now, though, which is every 2 years with your existing applications, processing efficiency is halved because the existing applications can't use all of those wide cores that are available. So that starts driving virtualization. Virtualization, we talked about an abstraction from hardware to the apps. Abstractions are great. It means that things can move. So workloads can start moving from one place to another. Yet we talked about networks where the fundamental IP network, the internet architecture was designed in the 70s and 80s, the addressing structure. We talk about how networks are dynamic, and they are. They self-heal. They find ways around problems. But the addressing is incredibly static. I was pulling my cell phone out, not because I was checking my email on stage, which would be fun, but because, could you imagine a cell phone that doesn't work from one carrier to the next, where your phone number changes every time you leave a building and go to another cell tower? That's the way the internet's designed today. We talk about cloud computing. We talk about driving efficiencies, and the efficiencies have astounding numbers. There's like 10 million servers that are depreciated assets that are running inefficiently that could be consolidated. That's actually like 2 servers for every citizen of LA, just north of us. Laid end to end, it's like 3,006 miles of servers. That's like here to Bermuda. It's a pretty amazing amount of equipment. And it draws power equivalent to the wind energy production in the US, which is about 3% of power in our fastest growing power segment. So there's a lot of interesting things that can happen if we can drive these efficiencies. But the internet doesn't support these mobile workloads, which leverage the abstraction, which let us break that one-to-one mapping that require us to use those spreadsheets and armies of clerks. If virtualization had to change the way we designed and built our networks, and cloud computing is arguably a form of virtualization at scale, it's safe to argue that cloud computing will break the underpinnings of the internet architecture that we're running on today.
That's a very great point. So maybe you're the proper person to segue us into this infrastructure 2.0, or what some people call dynamic infrastructure.
I would say that if infrastructure 1.0 was predicated on some of the adjectives we used of static, one-to-one mappings, fixed, we're looking at a world where the network, and I don't want to use network in like the Cisco sense of switches and routers and stuff, but the network of connected devices operates dynamically, where workloads are portable, where you break down the one-to-one mapping, where an IP address, I could take your email server and move it from your data center you operate to a service provider's data center because you need capacity on demand. And when you don't need it anymore, the workload comes back. A dynamic infrastructure of connected resources that still self-heals, but now self-optimizes, and now puts workload in the best, most efficient place to process it at that time. And that could enable follow the sun models, follow the law models, follow the kilowatt hour models, and so on.
Erik, what about the application delivery standpoint in terms of infrastructure 2.0? What does it mean?
Well, to put it in practical terms, one of the most popular applications out there used in the world is Microsoft SharePoint, a collaboration tool. It literally grows like weeds in an organization. There's a reason for that. It's a tool that most business units and non-technical people can use effectively to begin collaborating within their departments. As such, and it's also one of the more popular applications that we see that is being virtualized. Now, in a highly distributed organization, you'd want to be able to see that an IT organization that gets a request from a business unit that says, I need a collaboration tool, and spin that up and deploy it on some compute platform within their enterprise. Now, from an application delivery standpoint, one of the challenges with a product or a good product like SharePoint is that its behavior on the network, especially across the wide area network, is not always going to provide the best user experience from a performance standpoint. And it's not because it's SharePoint's fault, it's because of the combination of the way the application behaves and some of the variables that can occur in the network environment. Well, from an application delivery standpoint, what becomes important then is I spool up that workload, that virtual machine for that business unit, and you determine that that business unit is highly distributed. Yes, there might be some people in Seattle, some people based in San Diego, some people based in Beijing. In order to make sure that that application is secured with right access controls and accelerated to get the performance, because it's going to vary dramatically the difference between Seattle's performance and, say, Beijing's performance, depending upon where that actually physically resides. You're going to want to be able to automatically assign the acceleration policies. So it's a collaboration, and this is one of the key things, and I think why having this panel here is and the diversity is so important, because no longer in the infrastructure 2.0 world can we see silos of organizations. It's no longer just VMware's job or Cisco's job or Infoblox's job. It's all of us collectively working together to solve these problems so that when you do deploy this workload, the correct policies are set based upon where the users are, what devices they're coming from, without having to have an army of clerks.
That's right. Richard, from the transition, how we go from 1.0 to 2.0, what's that going to look like? What kind of shape is that going to take?
Well, it's interesting. One of the last things that Erik mentioned really is organizational as much as technological. Yeah. I was addressing yesterday a group of CIOs from the UK, and I asked them, well, do you know what you're spending on your network to manage it, just your IP space? And a guy from a large UK company says, yeah, well, we have 30,000 IP devices roughly, and we have 2.5 full-time equivalents. That's what we use to manage the network. And I said, oh, really? So you have a line item in your budget for all the things having to do with provisioning and dealing with all your core network services. What about the help desk? What about the server team? What about, and one of the challenges is there's no there. In most organizations, the responsibility for various parts of managing the network and these body of clerks are diffuse. There's no single line item, so it's very hard to attack. It's been a challenge for a company like ours because we provide tools that allow them to automate that stuff. And when what they think is, oh, I really only have 2.5 guys doing it, there's one level of ROI you can achieve with a certain investment, but when they really take into account all the resources that are being thrown at it, then they can see the investment. But today, it's buried. So one of the first things is for network organizations or for IT organizations to rationalize the way structurally they deal with all of their network operations. And they've got to get folks talking. One of the things we've heard from some of our VARs who build big data centers is sometimes they're sitting around and planning these great virtual data centers, and the application guys are there, and the server guys are there, and the operating system guys are there, but the networking guys aren't even in the room because it's just viewed as plumbing, right? It's always been there. It connects things, and it's going to work. And the problem with that is the architects are coming up with the idea of a house where you can put a plumbing fixture anywhere you want dynamically. Oh, in this room I think I want a sink. I'll just put it in. And it makes sense to them. What they don't realize is if you're not talking to the plumber, every time you want to do that, he's going to come out with a torch and cut pipes and instead of having a nice outlet there for you. And that's the part that really has to change at the beginning.
I can see that person, running a manual labor shop in textiles or something, and watching that and it's just machinery. I got people that can do that, so we're all fine here.
Yeah.
So, Mark, from a standpoint of virtualization and data centers and this network infrastructure, I mean, what's the implications for CIOs, companies, nations, cities, who build these cloud computing virtual data centers on static network infrastructures? I mean, where do they end up? Where do they go from here?
Yeah, so I love the topic. I mean, I don't think there's been a better time to be in the business than there is right now because of the opportunity that we represent to our business management and our leadership. But what I like to do is, I love analogies, so I'm really trying to compete with some of these guys here because they had some great analogies. But what I'd like to do is turn your question a little bit and talk a little bit about what, when it's done right, what that means for your environment.
Wait a second, that's not on the script.
Sorry.
You going off script here?
I know, I'm sorry. But if for most of us, if you think about the average enterprise today, we've built the equivalent of the Maginot Line or a Fort Knox for our primary data center. And in a larger enterprise, we might have a couple of these primary data centers and a few redundant facilities somewhere. And there's an incredible amount of cost that's borne by the average organization to do that, right? There's additional hardware that's required to support the building to begin with, and the cost per square foot of construction is often as much as 3 to 4 times what it would cost for just an average everyday good data center, right? And so in a company that's worth $2 or $3 or $4 billion, the cost per year for capital expense could run in the many millions. The initial one-time cost can run in the tens of millions to enable that kind of facility. And the worst part about it is that you've created a Fort Knox. Well, what's great about Fort Knox is there's so much stuff there, nobody can take it and put it in anything and get anywhere with it before they could get caught, right? And that's really what people think about with their data centers. And that's all great, but if a plane lands on it, or you have a serious earthquake, or there's flooding, then you still have to have a recovery location. So from my perspective as an end user of this kind of technology and what the opportunity represents is that when we can make the system's fluid and we can move them from place to place, we can take advantage of some of the things that Doug mentioned and the other gentleman mentioned about, low-cost locations, low-cost power, even putting applications in front of the consumer more closely as opposed to always having them wherever they were originally designed. And you can have facilities that are built more as just effective, efficient housing for these systems and build the protections into the application layer, into the platform that supports the applications. And this can literally, for a company that's spending $30 million on data centers on a yearly basis, it could be the difference between spending $10 and $30 million. It's that different. So for me, it's really compelling, and it's a story that certainly my leadership is bought off on, and pretty much everyone I talk to sees that vision and understands the opportunity. So that's why I think the work that all of these companies are doing is so critical to the future of our business. And like has been mentioned before, effectively 2 or 3 years from now, someone's going to come to you. It could be a Deloitte, or it could be a PwC, or it could be someone from the federal government, and they're going to say, what's your DR plan, and how many minutes will it take you to execute? Well, I've got a document that I wrote. We think it works, but it might take us a week to get the systems recovered. And that's not going to work, because 2 or 3 years from now, if you're doing it right, you'll be testing your DR every day. It'll just be part of your environment. Your people will be constantly trained on it. It'll be available all the time, and it'll be lower cost of ownership.
Good point. So, we've talked about it from a standpoint of a technology issue. Doug, in terms of the U.S. or global economy, what's the benefit of embracing network automation and, dynamic infrastructure 2.0? What is the benefit economic?
When in the 1980s, when we went to the MRP systems and APICs, just-in-time manufacturing, we looked at our supply chains. We connected supply chains. When we had a integrated and connected supply chain, we could build to forecast and build to true demand, as opposed to building to some guesstimate on how much we think we need in warehousing. So we were able to reduce costs. When we connected that supply chain and we scaled back and we pulled back, we would realize that I might get raw materials from the Far East. I might do manufacturing transformation in Jakarta and ship over here and then handle distribution and retail domestically in the U.S. Economically, that was the most feasible for the businesses, but at the same time did not exactly create a lot of jobs in the U.S. I think we're at the interesting cusp of what's happening in IT, because what we're talking about is creating similar just-in-time IT processes that enable the same types of economies of scale of rapid resource shifting that happened in manufacturing, the same principles to be applied to a static IT organization and static IT workloads. But if the infrastructure can't handle it, what will happen is when we pull back and look at that global supply chain, we'll find that maybe companies end up getting the power and the workload and the infrastructure outside of the US border. Now, whether that's good or bad is debatable, and in a nonpartisan way, I think we could probably agree the government's writing a lot of checks that might not be able to cash, and they're looking for funding sources. So what's intriguing to me is if we can build an infrastructure domestically that enables workload to be portable, build the right telecommunications infrastructure so that we can leverage the low-cost power infrastructure we have in the Pacific Northwest for computing resources to be used cost-effectively by multiple businesses with an economy of scale that drives efficiency, new business creation gets more cost-effective in America than anywhere else. If we do that properly, the power grids get utilized more efficiently and effectively than anywhere else, and the costs stay low. And if we do that effectively, we have a significant national resource, because now the infrastructure stays domestic, the power generation stays domestic, the knowledge workers generally would stay domestic, and job creation and the tariff and import duties get paid on infrastructure brought in to support that. So I think we end up in a very powerful situation if we as a nation and as a series of industries come together and take the power grids we were used to on one hand and the telecommunications infrastructure on the other, and bring those two together seamlessly to support more effective and efficient processing, mobile workloads, dynamic infrastructure, and the ability to create those decouplings, which then benefit the breadth of startup businesses that we want to foster inside the domestic tax umbrella.
That's a great point, especially on the new business creation. Because in essence, you can think of it as the democratization of IT. So a lot of things, and I've worked in many startups before, and it's very difficult to have a robust IT infrastructure, something that would mimic, the size of, say, Cisco's own internal systems. That is way beyond the accessibility of most organizations. What creating a dynamic infrastructure and virtualization does, and a lot of the cloud computing models, is it makes that those same systems available to the smallest company so that they can benefit from the efficiencies that have been proven out over time and time again in the large organizations. Everything from the Salesforce automation to the unified communications. And if we can build that infrastructure here, it is an enabler of and makes those new startups, so even the ones that you saw on the earlier panel here, much more efficient and competitive than those that you might find in China or Korea or Japan.
Absolutely.
But the alternative is if we don't make the investments in making the infrastructure significantly dynamic, both in the data center and over on the enterprise side, so that we can actually consume those services in a flexible way, then someone else is going to do it. It's just like with manufacturing. IT will move offshore, just as manufacturing did.
Absolutely.
It's interesting because when you think about the bigger picture economic implications, far before when any of us in this room were born, the Middle East was an area of thriving economically, intellectually, on multiple fronts. It was a source of incredible, massive wealth. Why? Because it sat between the Far East and Europe, and the spice trade had to pass through there across these paths, and along the way you paid for security, protection, they're toll gates, right? So with the rise of oceanic shipping, those toll gates became vastly inefficient, costly, and the European powers were able to basically develop a global infrastructure that used the ocean, similar to what we're talking about with the cloud, and decouple from those paths and basically maximize their routes based on cost, economics, and these factors. The net result to the Middle East, which is the implication for North America of this, is that, to quote Ross Perot from many years ago, there was a vast sucking sound of revenue that disappeared from the Middle East coffers over a period of time as the Europeans avoided paying for the cost of transport over that area. So now we have a network in North America that's been a source of, in the IT industry, massive amounts of jobs. And the question is do we want to build the infrastructure to create that next generation of jobs, the policymakers and the strategists? Any comments on that?
Let me add one thought to that. What we're talking about having to do is building a system. It's not, and a system, just like our, Nick Carr talks about the electrical grid is a great example. A system, you have a supply side portion of the system and the demand side. Both have to move in concert and in balance. But the system we're talking about is only as effective as the distribution medium of getting that utility and that supply to those who have the demand. Aqueducts were a wonderful distribution of water as a utility over the centuries and effective ranges of 50 to 200 miles. Electricity, we were able to get a couple hundred to 1,000 miles. We are talking about a utility, and the only one I know of that's global in reach. It self-heals, it's wired, wireless, goes where you need it, satellite, you name it. And getting that utility upgraded so that it can support any workload anywhere in seconds. Mobility done in software, no more hardware provisioning for capability, means that the utility is as responsive as the end users need it to be. And today it isn't. Today we're set up to have end user expectations that not only can't be fulfilled, but then drive cost centers where we don't want them to be.
We have about 30 seconds left. Are there any questions?
leaving ample time for the audience.
Yeah. Speak quickly. Oh, Dan? Oh.
Jump.
Probably used up my 30 seconds already. I really haven't heard any discussion of security in this whole thing. And you know, in my business, I do various data center moves, large virtualization projects, and things like that. And getting the network right is usually a long pole in the tent. You know, the guys can rack and stack servers, get VMware up. I work for Accenture, we use it extensively. But when you start getting into the network reconfiguration, things tend to grind to a halt. And one of the reasons is that the network engineers have tended to make, you know, fences inside fences inside fences for security purposes, which is bad enough, but then you've got the record keeping of all those IP addresses that's not up to date and everything else. So to get to the question, you know, with everything you've been saying about the more dynamic infrastructure, quickly, what's it going to do to take away the need for the complexity to support security requirements?
I'll take a quick stab and then defer to anybody else. The word static and security often went together really well, right? Because if it was static, I could secure it better. And the words dynamic was like anathema to the security guy because that meant things moved. And when things moved, I couldn't secure it. And we wanted to jokingly make a video, dude, where's your server? You know, because it moves around the data center and I can't find it. And if I can't find it, my God, how can I secure it? And the words that you want to apply to cloud computing that customers keep talking to me about are trust, control, interoperability. And so what we need to be able to do is extend a trust boundary, for instance, from an enterprise over here into a service provider. It has to be encrypted. They have to trust it. I have to extend my policy. My policy has to bind to the virtual machine and move with it without losing any accounting or any control over what's happening. Storage, data, mission-critical stuff to your business that sometimes has to move, sometimes can be abstracted, sometimes can be streamed. The data, when it's stored in a provider's network, is encrypted specifically with a key that's relevant and known by your business. And when I bring that data back, because it's mobile, when I bring it back into my shop or somebody else's, because it's interoperable, I move the key and I repudiate the right to access it once I've validated the data. So security has to be addressed from trust boundary extension, data retention, data repudiation, encryption, and also we have to create a highly effective illusion that the enterprise, the small, medium business, still owns what they own, yet support a large-scale multi-tenant environment so the economy of scale can be maintained and they don't have to make unprofitable infrastructure investment.
And implicit in all the things that Doug was talking about, well, just think about it. There were an awful lot. You mentioned a lot of things. I lost count at the keys and the...
Did I wax technical? I'm sorry.
No, but just from the number of steps involved, there is complexity. And the question, I think, had to do is how do we get rid of the complexity? Well, we don't. The complexity is there if you want all this great stuff to happen. But imagine if there was a manual sign-off and a checklist for all the things that Doug just said, if you wanted to be able to move that workload. You know, it would happen sometime next week, if at all. So implicit in all that is it has to be automated. And that's the big disconnect, or a big part of the disconnect between the network today, the 1.0 network, and the 2.0 network. If there's people in the loop, if there are manual processes, if there are spreadsheets and people are looking them up, alarm bells should be going off. Something's very wrong because that is antithetical to all of those possibilities.
Now, I would just like to add, I mean, the very nature of networks and security the way they are today is that they're like a perfect structure as long as you push on them the right way. But the minute you push on them the wrong way, everything breaks. And when it breaks, the complexity of resolving it and fixing it and getting it back to where it was is hugely burdensome, not only for the consumer, but for the person who owns it. And ideally, the future environment is literally that, where you have environmental security around an application set or a tiering of applications or user groupings that is applied as you use the application and goes away when you're done using the application and doesn't have to be applied at every layer of the infrastructure.
Right. So from an application delivery perspective, Doug hit on this, I think, extremely well. I can speak from F5's perspective. The way we view it is to be able to create that trust model, secure federation between people.
The police are
We
here.
have our
the police. Sorry. We can talk offline.
And we're going to be available, obviously, through the evening tonight if you want to ask us any other follow-up questions.
said.
So, thank you guys very much. Thank you.